All right, we're going to continue on with what we learned yesterday with equations of lines. And so a quick little review here as we open up. Remember that slope-intercept form is y equals mx plus b. We graphed using that method yesterday when we calculated slope. Point slope form, y minus y1 equals m parentheses x minus x1. Reminder that we talked about opposites. Okay, and then standard form is ax plus by equal to c. Your a, b, and c are coefficients and constants. Okay, if we look at the piece below, x and y are on the same side when we're in standard form. A, B, and C are integers, so no fractions. What that means is if I had, say, 2/3 x plus 4/5 y equal to, say, 6, I would have to multiply everything by a 15 in order to get rid of the denominators and get integers. Okay? And then the third thing is usually we make our a value positive. So instead of having, say, a negative 3x, we multiply everything by a negative 1 to make it positive. All right. So yesterday we looked at graphing 4x minus 8y equal to 24 using slope-intercept form. So we subtracted x and divided by negative 8. But what we're going to do today is we're going to say, all right, we can use this form, but what we can do is keep it in this form and find the x and y intercepts. All right? So over here on the left, just to explain this, I call it like the T method. So I'm going to give you, say, let's have a 2x plus 3y equal to 12. So notice, a is a 2, b is a 3, c is a 12. They're all integers. Notice that a equal to 2 is a positive number, so this is standard form. All right, so I call it the T-chart method. So I'm going to make a T-chart, and I'm going to start by plugging in 0 for x. Now, remember, whenever you plug in 0 for x, that means it is some number that is going to be on the y-axis. That means that this point here is going to be our y-intercept. So if I plug in 0 for x, that means I have 2 times 0 plus 3y equal to 12. Okay, 2 times 0 is nothing. So if I divide by 3, I can get a y value of 4. So therefore, this is the point right here, 0, 4, okay, is our y-intercept. Next, I am going to plug in 0 for y. If I plug in 0 for y, that is going to find the x-intercept, because all the points on the x-axis have a y value of 0. All right, so I come back up here, and I've got 2x plus 3 times 0 equal to 12. Well, 3 times 0 is nothing. So 2 times 6 gives me 12, so x must be a 6, making this the point 6, 0. So I can graph a line by finding my x-intercept and y-intercept and then connecting them. Because remember, we've talked about the idea you really only need 2 points in order to make a line. All right, so let's apply that to example 1 over here. All right, so I'm going to leave it in this form instead of converting into slope-intercept form. I'm going to make a T-chart. I'm going to put an x underneath the, or 0 underneath the x, solve for y. I'm going to put a 0 under the y and solve for x. So if I do the first one first, okay, if x is equal to 0, this all disappears, and now I've got negative 8y equal to 24. Negative 8 goes into 24, negative 3 times. All right, so now what I'm going to do is I'm going to start all over again. This time I am going to plug in a 0 for a y, and I'm going to have this all disappear, and I'm going to have 4x is equal to 24. Divide by 4, and I'm going to get an x value of 6. So this is my x-intercept. This is my y-intercept. So whenever I am trying to find the y-intercept, I plug in 0 for x, solve for y. Whenever I want to find the x-intercept, I plug in 0 for y, solve for x. Okay? So now I've got the point 6, 0, which is roughly here. And then I've got the point 0, -3, which is roughly here. And now I can connect them to form my line. Okay? Looking at another example, same idea. I make a t-chart, plug in 0 for x. 0x means 6 goes into 36 6 times. Start all over again. Plug in 0 for y, which means this all disappears. 9 goes into 36 4 times. So now I got 4, 0. This is my x-intercept. This is my y-intercept. So at 4, 0, I'm here. 0, 6, I'm here. And I can connect and form a line. And I would say that's probably just as easy as converting into slope-intercept form and graphing. All right. Next piece of information that we want to focus on is finding the distance between 2 points. So anytime we want to find what they call straight line distance, helicopter distance, the distance directly from one point to another point, we have the following equation. Now, this equation is based upon the Pythagorean theorem. So you learned at some point, hopefully, that a squared plus b squared equals c squared. Well, we're not going to use a and b and c. Instead, what we're going to say is that our distance up and down is the y value minus the y value. So y2 minus y1. That's where this comes from. And then the distance across is the difference in our x values. So this is x2 minus x1. Well, in terms of Pythagorean theorem, if I square this and square this, that is equal to the distance squared. Okay? But I don't want d squared, I want just d. So what I'm going to do is I'm going to take the square root of both sides, and I'm going to get this equation right here. So d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. All right? We need to know that formula, so we're going to practice using it. So over here, it says to find the distance between the two. All right? If it helps, just think about going straight across. x1, y1, x2, y2. As I said yesterday, if it helps to write the equation over and over and over again, think about doing that until you know it. Okay, so x2 minus x1 quantity squared plus y2 minus y1 quantity squared. All I'm going to do is plug in and simplify. So x2 is 5 minus an x1, which is -3, quantity squared. And then y2 is an 8 minus a 2, quantity squared. Following order of operations, change. This all becomes 8 squared. So I now have d is equal to the square root of 64 from my 8 squared, plus 8 minus 2 is 6. 6 squared is 36. And I'm basically following order of operations. I'm doing inside parentheses first, then I'm doing my exponents. Now I'm going to add them together, and I'm going to get the square root of 100. And when I take the square root of 100, I get d is equal to 10. Okay, so it comes down to just knowing our formula and following order of operations. All right, flip on to the second page. All right, they give you 2 points. They want you to do 3 things. They want you to find the slope, the midpoint, and the distance. All right, so slope. Quick little reminder. M is equal to y2 minus y1 over x2 minus x1. So m is equal to negative 1 minus 3 over 8 minus negative 2, negative 4 over a positive 10 after doing change, and that simplifies down to negative 2/5. Midpoint. Remember that midpoint, capital M, is equal to the sum of the x's divided by 2 and the sum of the y's divided by 2. We talked about how the midpoint is in the middle or the average. So now our midpoint comes from negative 2 plus 8 divided by 2 and 3 plus negative 1 divided by 2. This simplifies down to 6 over 2, or 3, and 2 over 2, which is 1. So there is our midpoint, 3, 1. Lastly, distance. Distance is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. I am going to just plug in and follow order of operations. So 8 minus negative 2 quantity squared plus negative 1 minus 3 quantity squared. Change. Distance is now equal to the square root of 10 squared, which is 100, plus negative 1 minus 3 is negative 4, squared is 16. That means it is equal to the square root of 116. All right, now one of the things that we can do with this is remember that 116 is divisible by 4. It is equal to the square root of 4 times the square root of 29. The square root of 4 is 2, so now we've got 2 square root 29. Always try and simplify your radicals if you can. All right, continuing on, review of our equations. So yesterday we talked about point-slope form. Big thing is remember that we talked about opposites. So when it says to identify the point, remember that the x value is a positive 9. The y value is a negative 2. The slope is the value that is in front of the parentheses. So m is equal to 4/3. Remember, these two pieces of information are helpful when we want to graph. If we wanted to convert into slope-intercept form, we are going to distribute and get y plus 2 equal to 4/3 x, and then minus 4 times 9 is 36, divided by 3 is 12. I am now going to subtract the 2 over and get y is equal to 4/3 x minus 14. So I've got y equal to 4/3 x minus 14. All right, standard form. Remember, x and y are on the same side. So I'm going to subtract the 4/3 over, and I'm going to get negative 4/3 x plus y is equal to negative 14. All right, two things that we talked about if we're going to put in standard form. Number one, we want a to be positive. Right now it's a negative. And number two, we said no fractions. We want integers. So I am going to multiply everything by the LCD, which in this case is 3. But I'm also going to multiply by a negative 3, because a negative times a negative will turn this into a positive. Okay, so now I'm going to have a positive 12 divided by 3, which is a 4x. I'm going to do negative 3 times y and get negative 3y. And then negative 3 times negative 14 equals 42. And so now it's in standard form because I have integer coefficients and an integer constant, and my a value is positive, and x and y are on the same side. That is standard form. All right, so after a quick little review of that, one of the things you want to think about is what is the best method in which to write an equation? Well, that'll all depend upon what information is given. So, for example, in example 6, I am looking first to see if I have a y-intercept. If I have a y-intercept given that I know exactly what point it's passing through, I'm going to think about using the slope-intercept form because I know that b is equal to 1 because it's crossing the y-axis at 1, and that my slope is equal to 2/3 because it's going up 2 over 3, up 2 over 3. So if m is equal to 2/3 and b is equal to 1, I can write y equal to 2/3 x plus 1. Slope-intercept form. Easy peasy. But notice, when we get to example 7, I don't know exactly what the y-intercept is. And since I don't know exactly what the y-intercept is, I am not going to use slope-intercept form now. Next, I am going to look to see if I can use point-slope form. Well, it's basically saying I have 3 separate points and I can write 3 separate equations. We practiced this yesterday when I had the girls write an equation using one point and the boys using another point. So first thing is make sure that we understand that A is the point -6, comma, and it looks like 5. Okay? All right, next, make sure you understand the slope. It looks like it's going what? Down 2 and over 5. 1, 2, 3, 4, 5. So m is equal to -2/5. Now, if you remember, yesterday we talked about the idea that slope is always constant. So our slope is going to be the same in all 3 equations. So the very first one, y minus 5 equals -2/5, and then x plus 6. For b, it looks like I have the point -1, 3. So if I have -1, 3, I now have y minus 3 equal to -2/5, and then x plus 1. And when I have c, it looks like I have the point 4, 1. So now y minus 1 equal to a -2/5, and then x minus 4. So I have all 3 of these equations. If I were to put them all into slope-intercept form, they would turn out to be the same. Last example. Write the equation of the 2 lines. All right, remember, vox hoi. We talked about that idea. Okay, our vertical lines are of the form x equals. Our horizontal lines are of the form y equals. Easy way to remember it, if it crosses the x-axis, the way this one does, it's x equals. If it crosses the y-axis, the way this one does, it's y equals. Now all I have to look at is where is it crossing. So, since it looks like it's crossing at 4, x equals 4 is the vertical equation. Since it looks like it's crossing at -5, I would say it's y equal to -5. And those are my 2 equations. All right, you have homework on worksheet 3B.2.